What actually is voltage? We hear words like 5 volts, 9 volts, or high voltage all the time. But what do volts really mean? Is voltage electricity itself? Is it energy? Or it is the speed of electrons? Not exactly. And today we are going to explain voltage in the simplest way possible, visually and without complicated textbook language. By the end of this video, voltage will finally make sense. Most people learn voltage through the water analogy. Current is like water flow, voltage is like pressure. Resistance is like a narrow pipe. And honestly, this analogy helps beginners. But electricity is not actually water. Electrons are not tiny droplets racing through wires. So instead of memorizing comparisons, let's look at what's really happening. Inside every metal wire are electrons, tiny charged particles that can move through the material. Normally, these electrons are relatively balanced. Nothing interesting happens. No movement, no current. But the moment a battery is connected, everything changes. A battery creates imbalance. One side of this battery collects excess electrons, the other side has fewer electrons. Now, nature always tries to restore balance. So, electrons begin wanting to move from the crowded side to the side with fewer electrons. That invisible electrical push is voltage. Voltage is not the electrons themselves, voltage is a force pushing them. The larger the imbalance between 2 points, the stronger the push becomes, and that push is measured in volts. The moment we connect a wire between both battery terminals, electrons suddenly have a path. Now they can move. That movement is called electric current. And this is where many people get confused. Current is a flow, voltage is the reason the flow happens. No voltage means no push, no push means no current. Here is something surprising. A battery can have voltage, even when absolutely nothing is connected to it. Imagine a battery sitting alone on a table. No wires, no circuit, no flowing electrons, and yet the voltage is still there. Why? Because the imbalance still exists, the electrical pressure is waiting. But without a complete path, electrons cannot continuously move. So voltage does not automatically mean electricity is flowing. Voltage is potential, current is movement. Now let's talk about high voltage. Larger power lines can carry hundreds of thousands of volts. Lighting can reach millions of volts. And visually, high voltage looks terrifying. Huge sparks, bright flashes, loud sounds. But voltage alone is not the full story. For example, static electricity can reach thousands of volts. Yet, most static shocks are harmless. They hurt for a moment, but usually cause no serious damage. That's because the current is extremely tiny and lasts for a very short time. Voltage creates the push. The current determines how much charge actually moves. Different devices need different voltages. A small LED may only need around 2 volts. A phone charger may use 5 volts. A laptop could use 20 volts. An electric car might use hundreds of volts. Why? Because different systems require different amount of electrical push to move energy efficiently. This is also why power companies use extremely high voltages. Higher voltage allows energy to travel long distances more efficiently. Less energy gets wasted as heat. That's why transmission towers use massive high voltage lines instead of low voltage cables. Now here is the strange part. Individual electrons inside a wire actually move surprisingly slowly, often slower than you might expect, sometimes only millimeters per second. But when you flip a light switch, the light turns on almost instantly. So how is it possible? Imagine a long tube completely filled with balls. Push one ball into the tube, and another ball pops out almost immediately on the other side. The balls themselves did not travel across the entire tube instantly. The force simply transfers through the system. Electricity behaves in a very similar way. The electrical signal moves incredibly fast. Even so, individual electrons move really slow. Another important idea: voltage always exists between 2 points. Voltage is a difference, a comparison. When we say a battery is 9 volts, what we actually mean is there is a 9 volts difference between its terminals. One side has high electrical potential, The other side has lower potential, and electrons want to move between them. So after all this, what is voltage? Voltage is an electrical push that drives charge through a circuit. Or more technically, voltage is the difference in electric potential between 2 points. Higher voltage means a stronger push, and that invisible push powers almost everything around us. Phones, lights, computers, motors, entire cities. Once you understand voltage this way, electricity becomes far less mysterious. Voltage is not electricity itself, it's the reason electricity moves. And now we finally know what volts actually mean.